What's up, guys? It's Thursday. I've got my sparkling water. That means it's time for Speed Clone. What's Speed Clone, you ask? Well, Speed Clone is where I find a animation or something on Instagram that I want to recreate that I think is cool. I put 15 minutes on the clock, then I see if I can clone it. Today's speed clone is going to be from Tasin Tariq. Probably butchering that name, but give them a follow. And they made this animation of some random crawlers, which I thought was neat. So, without further ado, I'm going to start my timer and get started. Okay. So we have these crawlers that are just crawling random paths, and they have lines connecting to different dots. So we need a collection of just random dots across the screen. We need positions for our crawlers. We need to check every frame that what dots are within a certain radius of the crawler, and then we need to draw lines to the ones that are within range. So, oop. All right, so, oof. Let's go. So first I'm going to make a global variable called radius, or I'll just call it R, and I'll set it to be 20 pixels for now. And we're going to make an array of points. And we're going to make an array of crawlers. So first thing we're going to do is we're going to initialize the points for I in range. So what I'm thinking we do for points is we just do a grid and we move each grid point to a random vector nearby, because that way they're spread out, but they're still random. So what I'm going to do is for I in range, I'm thinking in Python right now. Let I equal 0, I is less than, let's do, let grid, I don't know, density equal 10. So we'll draw a grid point at every 10 pixels. I is less than grid. Then height, I will be the column over grid. Density, I plus plus. For let j equals 0, j is less than width. For grid, density, j plus plus. We're going to add a points dot append. Nope, still thinking Python. Dot push new point. It's just going to be an object with an x and a y. So we'll do I times grid. Come on. Grid density yj times grid density. Come on. No, we're gonna do a vector. So P5 has a function called create vector that we can use. And then we are going to add a random P5 dot vector dot, oh come on, random vector. Random 2D. P5 dot vector dot, is vector capitalized? Yes. Random 2D. D is capitalized. Okay. And just to make sure our grid is there, for let point of points make our background black, set our stroke to white. Point. We're going to draw a point at each point. Go figure. Okay, cool. We got our random points. Let's make them a little more random. Dot scale 5. What is it? Dot mult. I think it's dot mult. No. There we go. So then we're going to make our crawlers. Let's have a global variable called num crawlers. Let num crawlers equal, let's say 7 for now. Canvas. No, what? For let I equals 0. We're going to iterate over num crawlers. I plus plus. Crawlers dot push. Create P5 dot vector dot random 2D dot mult. So we want it to be a random vector between width and height. So we'll say min height and width, just in case there. It'll just choose the minimum so we're not off the screen. And boom. So we got our crawlers. So then we're going to each frame, we're going to, oh man, 5 minutes to go. We're going to look at each crawler. We're going to, for each crawler, we're going to look at all of the points. So this is not, probably not the most efficient way to do this, but we're on a timer. Let points. If distance this between 2 points, okay. If crawler dot dist point is less than or equal to the rate to r, then we'll draw a line. X crawler dot y dot x point dot y. Okay. Cool. We're not seeing all the crawlers. Why aren't we seeing all the crawlers? What the heck? Crawlers not push right there. Height. Let's just set this to a constant for now. Oh. Hold on. Let's do this. Create vector in the middle over 2 height over 2 dot add a random vector okay, cool. Cool. Too far. Sweet. Okay, now we just need to make them crawl randomly. And this is not going to look like how Tassines crawled, but we are so close. So let's say we crawler dot add another vector, and we just randomly multiply it, or we multiply it by a random number in let's say max rand equals, or max step equals 10 for now. Max step. Oh, come on, why Okay, okay. This is probably, I don't know. You guys tell me if this counts. But that these definitely don't move as smoothly as to scenes. I'll call this a I don't know if we can call this a win. I feel bad about calling this a win. How do they get him to move so elegantly? Look at him just gliding. Well, time is up. We got something, and something is always better than nothing. But let's see if we can do a little bit better. Maybe if we just instead of just choosing a random vector, we instead just like alter the current vector a little bit, because ours just like choose a random direction and just jump, whereas these will move in basically the same direction. They won't make any big like changes in direction, they're smoothly steering around. Alright guys, so I actually tried a bunch of stuff to replicate how these guys are moving and couldn't come up with anything that worked. So I have an idea now of how I would do it. I'm going to go try that and I will post a follow-up video. But for now, I'm afraid I'm going to admit defeat. Tahsin Tariq, you win. Congratulations. Like, subscribe, guys, and I will see you next time.